Yeah, and I was so much looking forward to this, like each topic. But what caught our eye really was this post announcing Citus 10, and not only that, but also that they open sourced yet another part of Citus. So that's totally exciting, and I'm pretty sure we will hear more about this. So welcome.
Thank you.
Thank you.
Yeah, it's awesome to be here. We were so excited to get the invitation to come and chat a little bit more. And if this were a 6-hour event, we could fill the 6 hours talking about it, but I think we're going to keep it to less than that.
Yeah, I think you will get serious arguments from Niels, because Niels basically said the same about Spark.
I think you mean the other speaker.
Sammy?
I don't know much about Spark.
Oh, I'm sorry. Simon. Sorry, Simon. Okay.
That's all good.
Yeah.
So we'll be done by 8 a.m. tomorrow, Central European time.
Yeah.
Maybe we can start with a short introduction. Maybe you can tell the public who you are. Let's start with Claire.
Okay, so I work in the Postgres team at Microsoft, and prior to the Citus Data acquisition, I was at Citus for several years. I live in California, so for me, it's lunchtime and it's early in the day. I really admire all of you for being here in your evenings to be part of this. And I've worked in my career as a developer, as an engineering manager, and also as a product manager, and even in marketing at times. So I kind of change roles. And right now with Citus, I don't know, I put on my description that I'm a Citus open source champion, because I felt like that best describes what I do these days.
Okay.
Nils, what about you?
Yeah, so very much like Claire, I was with Citus Data before the acquisition, working on Citus, the database project. Still continuing that work today, but now in the Citus team at Microsoft, which is a sub-team of the Postgres team. And Citus 10 we spend a lot of time working on Citus 10. But even before Citus, I've always been working with data systems. I touched Spark a while ago, so I know a bit about it, but not enough for 6 hours. But I do know enough about Citus for 6 hours.
Maybe we should organize a separate session, just a full day session for you guys.
Maybe we can make that happen. Yeah. So okay, well, let's take it away, Nick and Claire.
All right. So Nils, I know you're going to do a couple of different demos today. But before we dive into the demos, for people who work with Postgres but maybe haven't heard of Citus yet, I thought we should just start with what is Citus? And I know you've got a couple of diagrams or things you can share and screenshots and things too.
Yeah, of course. I hope my screen is shared. Let's double check. Yes.
Yep, it's there.
Cool. So the first thing for Citus, open source meetup. We love open source. Please check us out on our GitHub page. It's either github.com/citusdata/citus or aka.mscitus. This is where all of our development happens. It's literally all the code is here. You can see us discuss pull requests if you want to. And then, I don't think many people on the call have heard about Citus before. So we'll take you through a journey and explain what Citus is. So to talk about Citus, we need to talk about Postgres because they're tightly intertwined. Citus is an extension to Postgres, so it's not a fork. Postgres is often forked, and Citus actually started as a fork, but 5 years, way before I started, we unforked from Postgres and became an extension, which is super important because then when Postgres comes out with a new version, because we're an extension, we only hook in onto the public points, and right after the Postgres release, we are up to date with the newest features Postgres provides us. But then on top of what Postgres provides, we provide a couple of extra features which make the database kind of a superpower. So the two most important features that we'll touch on today are distributed tables and reference tables. And inside Citus 10, we added a lot of new features. then when you use those features, the distributed tables and the reference tables, you can use Postgres at any scale. So when you want to add more nodes to your cluster, you can add them. The data gets rebalanced. So that's kind of in a nutshell what Citus is. So when we talk about Citus, we can kind of like talk about how to transform Postgres into a distributed database. But to do before the how-to, we should touch the why. So Postgres is quite a long-standing project by now. This is the design paper of Postgres. And in the second bullet point in the abstract, they already mentioned it. Provide user extensible data types, operators, and access methods. So this paper found it super important that Postgres had some extensibility. Over the years, more and more got extensible: the planner, the executor, transactions, foreign data wrappers, and background workers, just to name a few. But this is all that we use.
I think is, can I just jump in? What I think is so cool about this is that, like, I've been working with Postgres and on Citus for years before I actually went back and read this paper. And for me, it was just so cool to see that one of the design principles from the very beginning back in the 1980s was this ability to create extensions, right? Number 2 on the screenshot that you're showing right now. And I don't know, it just boggled my mind.
So. You already mentioned it. This was published in 1986. It still boggles my mind till today how forward-looking they were, because we're not only extension. PostGIS is a big extension that people use, but they all use kind of like, they built on top of this foundation.
Yeah.
That brings us actually to the whole ecosystem around it. So by not forking Postgres but extending, we can use all the Postgres tools. They keep up to date, we keep up to date, and together it forms this the web on the right. There's so many tools you can use when you build on top of Postgres. And not completely unimportant, over the years, Postgres is getting more and more loved by developers. You see a steep increase over the years of the popularity of Postgres, where the other SQL databases are very stable, maybe even declining a bit. Postgres is showing no signs of stopping that.
And actually,
yeah, go ahead.
Do you mind flipping back 2 slides to the ecosystem slide? I just want to give a shout out to the Efficiency Geek account on github.com, which is where we grabbed this screenshot from. Somehow my annotation of the source of that diagram went away. And so thank you. It's a wonderful diagram of this massive Postgres ecosystem.
Yeah, and it's not only the tools, but also these diagrams are part of that ecosystem that helps a lot with resources.
Cool.
Why Citus? So Postgres, as we said, is like super powerful, has extensions for geospatial data and others. But there's always like this limitation that like keeps you hesitant to try Postgres or like build on top of Postgres if you're fearing that you will run into the limitations a single node provides. There's a whole list of things, but it boils down to basically 3 things, in my opinion. You either run out of disk, which is what a lot of people think about when one machine gets too small. Memory is another important factor, and CPU. So for a long time, you bought bigger and bigger machines to keep your database running up until the biggest machine money can buy. But with Citus, we take that limitation away. So when you run out any of those dimensions, you can just mix and match by adding new machines, which adds new disks, new memory, new CPU cores, just to suit your workload. And then the second big reason is like, why on top of Postgres? There's a lot of companies in this space. They all take different approaches. Some build databases from scratch. We decided to build on top of Postgres, and the huge ecosystem around it is just what gives its benefits. Every year, Postgres comes out with a new version, new features, and you can use them quite quickly within Citus, together with all the other extensions that come out of the community. So those are kind of the reasons like why to distribute Postgres. Now we get a bit more technical. So it's a cluster of machines. They're all just Postgres machines. You install Postgres from the official repositories, and then you add the Citus extension on top of that. And then when you're in your database, you use some SQL commands to create the extension and add the nodes to your cluster. You do this from the coordinator, which is a special node in our system that you will be mostly interacting with. Once that is done, you can start creating your tables. And it starts like Postgres, like it's just Postgres. You create a table. And then the magic happens. You call this user-defined function, or UDF. That's called create distributed table. You give it a table name and the column you want to distribute on. And you tell that to the coordinator, and the coordinator creates tables on all the workers. And once that is done, it gets back to you with a result that it worked. Once the data of like your tables are distributed and you've loaded your data, you can query it just like a normal database. But there's a lot of things happening under the covers. So when you want to know the average spend on your campaigns, you see already in animation, like you send a query, just a normal SQL query to the coordinator. The coordinator sees that it is a distributed table. And the average you cannot just send to the workers and get it back. So instead of that, on the right-hand side, you can see that we ask for the sum and the count of the spend. We get it back on the coordinator from all the shards. And then we do the final computation to get to an average from the sum of sums and sum of counts divided by each other. So the power here is you use your normal SQL, but under the covers, it fans out to this cluster of machines to compute on top of your data. Actually, now we're getting into the Citus 10 area. It becomes easier and easier to run Citus, and today we can actually run it via one Docker run command. So like you would try out many different software packages, you can run this, and then you can get up and running quite quickly. You create your users table, you can distribute it, and then you can query it like normal. So we will quickly go to a demo to show that this works. So that said, we just start a container, and then we connect via pSQL. pSQL is the command line interface to talk to Postgres. I like it best.
Can I ask a question of Suzanne, and just to check on the font sizes? Can you guys see that okay? Is it good? All right, sounds like it's good.
Cool. So we create our table. It is a very simple table. We have a serial primary key and a name. We distribute our table via the command that I showed on the slides earlier. And now we have created like all the shards that we need. When you insert data, we'll just insert some names into our users table. It's all like, you can't distinguish it from Postgres, and that's kind of like the good idea. Like your application can just talk to Postgres, and underlyingly, it scales out. So when you query it, count, you will just get the count back. But if we look at an explain plan is kind of a technical thing, but it tells you a lot about what the database internally does. So in this case, we can see that there's a couple of steps involved to get to the count. Explain plans already look scary normally for Postgres, and now Citus adds a lot of things on top of it. But the important part for Citus is the part here roughly in the middle, where we have some hints that it's Citus, but the important things to take care of, like, take note of, are the tasks. So in this case, we see that there's 32 tasks scheduled to answer this query. And out of those 32, we show one. So you can kind of get an idea of what your data nodes are doing when you send this query. So actually, because it's Postgres, we just sent it a SQL query that counts its local table. And you see that the table name of the query is like changed. We added the shard identifier to it so that it is distinguished within the remote Postgres server we're talking to. We take the count from that machine. So in the end, we get 32 counts back. And then the final step that happens on the coordinator is that we take the sum of those counts to get to the count. So this is the power that Citus provides without thinking about all these steps you need to do to like query a dozen machines. You just write your SQL as any day. Besides going out to all machines, a big portion, what Citus does is also recognizing when you don't need to go to all machines. So when we look, for example, at one user's data, we'll again open an explain plan. Here we've added a filter that we're only interested in user 5. And because we've distributed our data on the user ID, this data is assigned to one machine. So here we see that there's actually only one task scheduled, and it sends the query quite verbatim over. So this also shows that the compute now linearly scales because most of the compute happens on the database node that has the data stored next to it.
So is that, I think that's why we have so many customers who are SaaS customers, where their data model is multi-tenant by definition, right? They have a lot of their own customers, right? And all that data gets co-located together for each of their SaaS users. Is that correct? And
that is correct.
So that data model is just ripe for scaling out and using, say, that customer ID or the tenant ID as a sharding key. And it makes it easy to distribute the database across shards and across multiple nodes and give everybody the performance they need. So.
Yeah, no, that's correct. And a big observation that we've done over the years is that those SaaS companies, we call them multi-tenant SaaS mostly, they have a lot of data. Their data is either too big on the pure size or on the compute they do on top of it because of the amount of users they have. But if you start looking at their users, their data is relatively confined and never exceeds this, either the compute memory or disk that one server can provide. So this helps a lot for those companies to scale out.
Cool.
That brings us to Citus 10.
Okay, so I think I want to talk a little bit about some of the exciting new stuff that's in Citus 10. Nils, just a quick heads up to you. I could tell from your earlier slide and the screenshot from DB Engines of the different database rankings that you have the older version of the slide deck that you've been sharing. So I don't know if you want to pull down the new one while I chat for a little bit about Citus 10, or I can start sharing, one or the other. But I like how you flip back and forth to the demos. So if you can find it.
I will just close my PowerPoint and open it again.
Okay. Or grab the shared one, whichever. So for Citus 10, what I want to talk about is the whole reason we got invited is we do have this like really big accomplishment that the engineering team has been working on for goodness, I don't know how long, 6 months, a year. It's been a long time. And the URL that Nick is so kindly showing on the screen right now, aka.ms/Citus10, will take you to Marco Slot's blog post. And the blog came out about 10 days ago, and it walks through some of the big things that are in Citus 10 and even some of the small things that are in Citus 10. And Marco is the technical lead. He's also based in the Netherlands, outside of Amsterdam. And he was probably involved in recruiting Nils to the team a number of years ago.
Yes, definitely.
And Marco has been part of Citus since pre-acquisition and probably for about 7 years now. Anyway, so he's a good writer. So it's a really interesting blog post to kind of dive into all of the different things. And if you jump ahead to the next slide. So, this is a release graphic. Actually, go back one. The Postgres community has a long history of having release graphics for different releases. And back in the Postgres 9.2 days, they had this super cool race car with an elephant in it and a scarf blowing off into the wind. And so about a year ago, we started creating release graphics for each one of our Citus releases, and we riffed off the race car. But we would always put like one of our Ellicorn, that's our mascot, one of those labels and stickers on the side of the vehicle somewhere. But for Citus 10, because there are some things that really changed the definition of how you can scale Postgres, we made it this funky hovercraft thing that can drive and can fly. And anyway, so the designer who created it is super freaking awesome. So thank you, Isaac, for that. Okay, so going forward, there are a bunch. This is that link to the blog post that I talked about that you can find online if you want to dive deeper later. But if we go to the next slide, there's kind of 3 big things that are in Citus 10. Yeah, still the old slide deck there that I can see. See the little yellow note?
I see.
So maybe I should share. I don't know. Would that be easier? Okay.
Yeah.
So let me bring this up and okay, I'll click on share and we'll see if this will work. Oh, but now I'm sharing without sharing. That doesn't work. So share screen. Okay, it's easiest with 2 monitors. I don't have 2 monitors. I have 1 monitor. So there we go. You're going to see this whole mess. And then I'll go like this and it should be good. So what do you see? Do you see the blog post? Yes, no, maybe?
Yes, it's there.
Okay, cool. Awesome. All right. So there are a bunch of different things that I want to talk about, these 3 big things in Citus 10. The first is that most people associate Citus with a distributed cluster. Maybe it's just 2 nodes, maybe it's 4 or 20 or 100. But we actually have now enabled Citus on a single node. So I want to dive in and talk about that a little bit and what it means, because it means a few different things. And then the columnar compression, that capability, bringing that to Postgres, and the fact that you can have columnar tables and row tables is a really big deal to do that in the context of a Postgres open source offering. And then the open source shard rebalancer is the thing that Suzanne mentioned in the very, very beginning. This is an important piece of Citus that we have now open sourced, and it's available for anybody to use. And we are super excited about that. So I showed the screenshot already of the blog post. You guys can follow up and read it later if you want to dive deeper. But for Citus on a single node versus a distributed cluster, one of the things that's historically happened is when people they go to adopt Citus, they've typically had an application that's running on single node Postgres for quite a while. And then they finally started to hit the limits, hit the ceiling of that single node. Maybe they couldn't keep all the data in memory anymore. Maybe query response times were getting longer and longer. Maybe certain peak times of the day when their users were really active, that's when performance would start to get sluggish. And so then people would go through a migration, which to go from a single node Postgres to using Citus. And the migration was typically not that hard. You didn't have to re-architect your application or anything, but you would have to make sure, and Nils, keep me honest here if I don't describe it properly, but you'd have to make sure that you had, you decided on what your distribution column or your sharding key would be. And then you'd have to make sure that that sharding key existed in all your tables, particularly when you needed to join things. So you might have to make some adjustments to your data model in a few places. And we would hear from people, like I can remember talking to one customer in particular who said, you know, I wish I just started with Citus from the very beginning. Even back when I was on a single node, it would have saved me the 3 weeks of migration later. And so that's kind of what we've enabled now. You can now shard your data and use a distributed data model on a single Citus node, even before you're ready to scale out and use a distributed Citus cluster. And that actually opens the door to a bunch of different things, including like maybe you have Citus as part of your CI/CD pipelines, or maybe you just want to try it out. And like Nils showed you earlier, that simple Docker run command, right? That's new as of Citus 10. We've made that so much easier to try. Testing is easier now. People can get started on Citus now. This piece of feedback is really interesting. It came from our open source community Q&A forum, which is on Slack. The URL should be showing in a green bar on the left side. And I think, Nils, you picked this out and wanted to share it because we hadn't even...
I saw this a couple of months ago. It was actually when we first started experimenting a bit with single node and what Citus could be with a single node. We wrote a blog post about it. We did the bare minimum work that we needed to do. Mm-hmm. And then this user came, like, I think the day of the blog post or the day thereafter, thanking us how this was you can see it on the fourth line from the top, a lifesaver for him in his CI/CD, and it was something I personally did not think about.
Yeah, it's definitely one of the use cases for it. And thank you to Ivan. He gave us permission to use the screenshot outside of Slack and share it with all of you today. So, and then we're going to talk about columnar tables as well. And you can now use columnar tables with Citus on a single node or in a distributed cluster. And you can use them with, sharding or without sharding. And so there's a lot of flexibility built in now for kind of different ways that you can scale. But this single node capability should make it super easy for people to try it, adopt it, use it, and we're excited about that. Did I miss anything, or can I jump on and talk about columnar? Nils?
Yeah, no, this was spot on. Single nodes.
Okay. All right. So now we'll talk about columnar storage. So I'm just putting these icons on the screen to kind of help you visualize that, there's different ways to store your data on disk, and that can have an impact on your query performance. And it can also have an impact on the storage. Like a lot of when I describe this new feature, this in Citus 10, I'll often talk about columnar compression, just to drive the point home that when you use columnar storage, you can often get compression ratios of like 3 to 10x or more. And so I think I'm going to walk through and kind of lay the groundwork for a mini demo that Nils is going to do that'll show you some of the performance benefits. Well, I think this is what he's going to show you. You can correct me. But when I think about columnar, you get compression benefits, which can save you on storage costs. You get performance improvements, especially when you can skip over unneeded columns because the data is laid out in that way. And you also are using less I/O because you're using less storage. And so that can speed up the performance of your queries as well.
There's often an extra angle that databases take. We're not there yet, but some computation can be done faster if it's laid out in a columnar format. Postgres does not support it at the moment. People are working on it within the community.
Cool.
But for now, it's mostly the compression and the skipping of the columns that you don't need. And those two together give a big benefit when you run, mostly in the cloud actually, because of the managed disks. They are network attached. You need to read less data from those disks to get to your answer.
So what's cool in Citus is you can use your row-based tables as well as your columnar tables, and they can both coexist within the database. And so not everything has to be columnar, not everything has to be row. You can kind of pick and choose. And in fact, we'll also talk about how columnar can be used with native range partitioning or time-based partitioning, people sometimes call it in Postgres. And that can be super useful too. And that's I have some graphics to kind of help you all visualize what I mean. But first, Nils wanted me to be sure to kind of share this SQL code to show how simple it is to create a columnar table. Like if the first create table command up above, that'll just create a normal table in Postgres that'll be a row-based table. And then the second create table command that's showing has the using columnar at the end of it. And that's pretty much the syntax you need to use in order to create a columnar table. The other thing that's probably worth pointing out is you can convert an existing row table to be a columnar table, and you can convert a columnar table to be a row table. And so you have a lot of flexibility over time. Obviously, or not obviously, I should also point out that columnar currently does not support updates and deletes. And with relational databases, as data changes or maybe you need to correct bad data, people do use updates and deletes. But what's super cool about this kind of mix and match and being able to go back and forth capability is that something can be a hot table, a row-based table today that you're updating and deleting. But then in the future, as that data is in the past and isn't going to change, then you can convert it to be columnar and compress that data. And that can be super useful.
I think if we move forward in the slides.
Then we'll show that, right?
Yeah.
Okay. So I'm gonna walk you through kind of some graphics to visualize using columnar with partitioning, time-based partitioning in Postgres.
So what we see on the screen now is actually the syntax for Postgres to create those partitions that Claire was talking about.
Yeah, so you create that parent table, which is called events in this case, and then you create the partitions. Let's say one of them is called events underscore 2021 underscore January, and the other one is for February. And these are both just native range partitions if we use this. And then that, if you were to visualize it graphically, might look something like this, right? You have the parent events table, and then you've got these row-based tables, partitions, one for January, one for February. And then the ... on the right is like, well, I created this slide back in February. March didn't exist yet. So, all right. And then if you were to take the January partition and convert it to be columnar, and this is using a new Citus function, right, Nils?
Yeah. Yeah, we inspired it on the syntax that Postgres normally uses.
Okay.
However, Postgres is very extensible, except for the syntax. You're not allowed to alter the syntax. So for this, we use a user-defined function again, which is called alter table set access method, which changes the access method of a table. And the access method is the internal terminology that Postgres uses on how to store the data underlying it.
Awesome. So then what you could imagine is that the January partition is now columnar, and we tried to use a little C-clamp to show that that data has been compressed. So all the data is still there. It can be queried. Queries are probably going to be faster, right? Because you can skip over unneeded columns and you're not using as much I/O in order to query that table. But if this were still February, which I know it's not, but if it were, then the February partition could still be updated and deleted. It's still row-based, etc. And so you can have many updates. And over time, you can imagine, like in this events table, for time series data, obviously, that the most recent partition could be row-based, could be hot, could be getting updated and deleted, and you can easily compress using columnar all of the older partitions. And I think it's a super powerful new capability, and I think this graphic kind of depicts it well, but not as well as the way Nils is going to show us in a demo momentarily. But before he does, also from Slack, and this person gave me permission to take a screenshot and share this with you today too. But this was so cool because Marco's blog post was published on Friday, March 5th. Yeah. And literally later that day, I don't know what it was, 6, 7, 8 hours later, he said that, he was able to shrink his append-only table from 80 gig down to 6 gig. And, Citus is easily his new favorite thing, and Postgres is now easier to grow with and scale out than most anything else. And this was completely unsolicited, and I was just very excited to see all of this hard work paying off for our users, which is cool. All right, so I think time for you to steal the screen back, Nils.
Yeah, if somebody puts my screen on again.
Okay.
Keep the presentation open because I still can't figure out how to get to the latest version.
Okay. Cool.
So we're back in the terminal. This is now not running in a Docker container at the moment, but on my local machine because I want to show some more capabilities outside of the single node Docker container. So we first start with creating a new table. This time, no, that's not a new table. We're going to create a new table, an events table, and it's very much like the table that we just saw. It's partition-based. We create the partitions below it. So this was the diagram that Claire was showing us earlier. And if we then insert data, just some random data within this time period, we can actually look at the data sizes. So I'm using \d plus to look a bit into the description of the schema within Postgres that we're in. And it's also showing us the data sizes that we're working with. So here we see that there's 3 tables that we're interested in, the events table, and then the 2 partitions of January and February. You can see they're roughly around the 30 megabyte mark. But January is closed, February as well as a matter of fact. But January will definitely not get updates anymore. So when we use that alter table set access method, it's just one command, you run it, it's done pretty quick. And if we now look at the description of the data in the cluster, we can actually see that it shrunk from 30 megabytes to 7 megabytes just with that one command. You can see how this can either speed up your queries or can like extend the history you can keep on your hardware for like months in the past. So that is quite powerful. Not as impressive as the user that was shrinking from 80 to 6 gigabytes, but generally we see this kind of compression ratios. Back to you, Claire.
Okay, and if we can do the webcam for a second before we share our screens, I just want to flag one of the giveaways. I saw a little message shoot across that for the people who have cool questions, which we need to open up to at some point. This is one of the giveaways. We're going to be sending out about 5 of these, and it's a Postgres activity book. And even if you don't have kids, it's kind of fun. You can see that I colored in that one. There's just really cool elephants doing fun things and a couple of activities, and I don't know. It's got lots of Easter eggs in it. So we thought it was cool. And Nils, you have some socks too.
Yeah,
that are
these are kind of like the pre-acquisition socks, as we call them. We're not making them anymore, but it still has the old company logo on it.
Got
Let's
it.
see if we can get it in there.
We do make new Alicorn socks, but they have a Microsoft logo now.
Yeah, so these are now collector's items, but we can still give them away tonight or this morning if you're on the West Coast.
All right, so let's jump to my screen again. I actually just got a question over chat from someone who was trying to understand, like, well, when would you want to use Columnar and what kind of use cases? So I grabbed this from a video demo that one of my teammates, Jeff Davis, made, but there's kind of 4 main use cases where Columnar with Citus and Postgres might be super useful. And we've talked a little bit in the example that we just did about the second one, right? Time series data, right? But there's other kinds of customer-facing analytics dashboards where having really low latency, having super quick response times is really important to your users, and you have a lot of concurrency as well. So you need the parallelism, but you also can benefit from the compression of using Columnar with Citus. We also have a lot of multi-tenant SaaS customers for Citus, and we also serve a lot of mixed transactional and analytical workloads. So those are 4 of the use cases you can think about when you think about scaling Postgres in these ways. All right, so we did the demo of that. And so now I want to talk briefly about the open source shard rebalancer.
That's so exciting. I'm really happy that it's open source.
I am too. I really am. And we've gotten a lot of positive feedback from users who are like, oh, yes, thank you. We're so excited. Hjelte Venema published a blog post about 5 days ago on this topic. I did not give you a link for that, Nick, but if you go back to that Citus 10 blog post, it links off to this one as well. And this diagram is meant to show you a situation where, let's say you have 2 worker nodes in a Citus cluster, and typically they would have more than 3 shards on them each, but we just put 3 shards on node A and node B, each for purposes of illustration. And we've added a new node, node C, but it's empty. It's not doing us any good. It doesn't have any data on it. There are no shards on it. And so that's when you would want to use the Citus shard rebalancer. And I just moved that diagram over to the left. And now on the right-hand side, you can see that the shard number 3 has moved down to node C, and shard number 6 has moved down to node C, and now they are going to be balanced. And there's a simple command that you can run in order to do this, and then writes to the shards that are being moved are blocked while the shard is being moved, but writes to all the other shards and the rest of your database and reads and everything will all still continue to work. So anything you want to add, Nils, to that? No,
it's mostly like when you create an index, Postgres needs to take certain locks to guarantee data integrity. We need the same when we move this data around. So we can't move data around while we change it. So the blocking rights sounds scarier than it is, but it's kind of like an important to guarantee the consistency of your data.
Cool. Yeah, and we I don't know if we've mentioned yet, we've been talking about Citus open source this whole time, but Citus is also available as an integrated deployment option, a built-in deployment option for you as part of the Azure Database for Postgres Managed Service. And so some of our teammates work on the Azure Managed Service side of things for what's called hyperscale Citus. And there, I think we have some tricks, so it doesn't block there.
They are complicated, so there's ways of getting around it that so far is only available on the managed services.
The other use case that's maybe if you work with Postgres a lot or with Citus, you already know about this, but it's not obvious in the beginning. Like, obviously, if you add a node, you're going to want to rebalance. But the other time you might want to rebalance is when things kind of get out of whack. Maybe you have some particular users or some particular shards that have gotten a lot bigger. And in this case, I'm depicting shards 3 and 4 as taking up a lot more footprint on node B. And so that might be another instance when you want to rebalance things so that the workload going to node A and node B is more in balance. And so in this case, you can see that shard 2 gets moved over to node B and shard 3 gets moved over to node A, and now they're balanced again. In Hjalti's post, he also goes through a lot of different rebalancing strategies. So there's the default strategy, but then there's some other ones that you could specify as well. So
it's even it goes further. You can write your own strategy. If you have a very specific way in which you want to balance your data, you can write a couple of predicate functions just in any language supported by Postgres, and you will get called to get the costing of shards, and then it will balance it out.
So are you going to do another demo? Do we have time?
It's a small demo. It's basically just a scale out. So if we can quickly switch the screens. We're still on the cluster that we created with the users table. We started on a single node with not distributed tables. We can quickly distribute the events table. As you will see, it copies the data around. And now, if we look at the contents of the Citus tables view, it's kind of a tool the same as /d is for Postgres. We add this view so you can look at the tables that Citus manages for you. And now you can see that the events table is distributed, but we're still only on one node. The way that you can see that is this system catalog table. It tells us that there's only one node currently in the cluster. But the good thing is you can easily add nodes if you install Postgres and add the Citus extension to it. I've done that with these 2 nodes beforehand. So if we then verify, we see that there's 3 nodes. And the most important thing is at the right-hand side, they're all marked to that they should have shards. But as Claire mentioned, when you add a node, they don't directly get data. So to do that, there's one final function that you can now use in open source, and that's rebalance table shards. It does all the calculations, and you can read all about it in the blog post of Hjalti. But it's calculating the most optimal way of your data distribution based on those cost functions.
Awesome. Thank you. So I don't think we need to share screen for a second. We can just be us, although I do have a few more slides to throw out there in terms of resources and things I want to point y'all to. There is a question that I think is really interesting that came in, which is the use case for developers is clear. How does one convince their tech lead or employer to adopt Citus?
And that's great. I actually had that discussion with a friend of mine about a week ago.
Okay. Well, do you want to take the first crack then? Go for it.
So they are on Postgres already. So all their team knows Postgres, and it took them a good while before like everybody was comfortable with creating tables, querying the database. But now their whole engineering team, and it's bigger than you would think. So it's like somewhere between 100 and 200 people, I think. Most of them now are comfortable with Postgres, and they have internally the discussion to move to a NoSQL database. And we were talking, and I kind of gave him the sales pitch of like Citus. It's like, especially for that use case, you're already on Postgres. It's like, why? And you spend like a good chunk of your time, let's say 6 months or a year, for your team to get comfortable with it. So they are actually now internally discussing if they should, instead of going to NoSQL, to scale out Postgres via Citus. So I think the best one is if you're already in Postgres, it's like, and you need to scale out, give Citus a try.
I was talking to the CTO of a company once. That's one of the nice side effects of being a champion, is that you do get invited to talk to users. And he was showing me the math. He literally did the math to calculate, like, if he were, instead of using Citus to scale out Postgres and basically keep the application pretty much the same, right? He had to fix the data model in a few places and make sure the distribution key was in all the tables. But he did the math to say, okay, what if I were to re-architect my app to do manual sharding, for example? And those engineers would not have been available to work on features for his customers. They'd instead be doing database work for that period of time, and not just for the 9 months that it would have taken them and all the feature work that he wouldn't be doing to get competitive, but it would be an ongoing cost, an ongoing opportunity hit, because every time they added a new feature, they'd have to make sure that it works with the manual sharding model, et cetera. And so when he did that math, it was clearly more affordable and better competitively for him to adopt Citus. So that was his experience. I hope we answered that.
Yeah.
I do want to.
The question there was, how difficult is it to change to Citus? I think that can range from, you can do it on a Saturday, or it takes you a couple of weeks, because the SQL support is 100% if you can push down all the work to the worker nodes, meaning there is this equality filter, like on your distribution column. In my earlier examples, when you looked at the users table, when we selected the user by its primary key, we only were sending a query to one node. As long as you join on that column, all the work can be pushed down into the worker, and you don't have to change anything in your app to get there. Sometimes not all the tables will have that column in there. So there's two strategies that you can take. You either backfill the data into it. If you're multi-tenant SaaS, the data belongs to some user, let's call it a tenant. You can add this tenant ID column to all your tables, backfill it with some SQL. That is quite doable. And then you kind of change your application to add those joins to your queries. It takes a while, but you can get there. But like, once you get to this stage, you either need to do this work or you implement a whole new database in your backend system. So that is kind of the cost of that is also not zero, mostly.
I know we probably have a few more questions to get through, but if I can share my slides for just a few more seconds. I can't see if they're showing or not, so maybe tell me when they are. Okay, cool. I just wanted to say that there's a really good blog post, and I know because I helped author it, that goes really, really deep into this particular customer story. And Min Wei was a customer of ours, actually, even before the Citus acquisition. And he uses Citus and Postgres running on top of VMs on Azure because, of course, he started using Citus before we were integrated into Azure Database for Postgres. And it's a really interesting analytics story where he's got a lot of data that they pull from, oh my gosh, it's a massive number of devices all around the world, Windows devices, and they pull all the telemetry and they pull all the data and they analyze it in order to make ship run decisions. So if anyone's curious, I think it's a really good story.
Yeah, that quote is really good. Distributed Postgres is a game changer. It is kind of like the moment that you can scale out Postgres, it gives you so many powers. And going back to that discussion I had with a friend, I actually brought up this blog post as well. I had the number wrong. I thought it was more than 1 petabyte. So I needed to send him a message back when I got home and verified it, that it was only 1 petabyte. And he kind of like laughed about that.
Does anyone know what the game is in the background of this graphic? Does anyone recognize it? No? Anybody here? Okay. I think it's Parcheesi anyway, which I have fond memories of playing as a kid. If you want to try out Citus on Azure, which is one of the easiest ways to do it, you do it as part of the Azure database for Postgres managed service. And you can see in the lower left-hand corner of this screen, I've got an arrow pointing up to it, that you would provision a Hyperscale Citus server group. And then, Teresa wanted me to be sure to flag the Citus newsletter. It's this monthly technical newsletter that comes out full of links about Postgres generally, as well as Postgres stuff happening on Azure, as well as Citus open source stuff. So that is easy to sign up for, and people find it useful. I helped write it, so I'm a little bit biased when it comes to promoting it. And yeah, that's what I had in terms of links and stuff. And I can stop sharing or I can keep sharing. I don't know if we have more questions or if it's time to pass the baton. So
thank you very much for this. I can imagine that you can talk about this for hours. And at least I enjoyed it. Looking at the feedback, the rest of the people are enjoying this too. So yes, obviously it is like you always have some cost when you want to move to a different model, and you want to, like for instance, you want to move to Citus. I think when the cost is not zero, but hearing this, whatever you do, there are sometimes so many things you can benefit from. Totally worth the investment and a weekend of pain.
And if you're not directly doing SQL yourself, but using an ORM, there's a couple of ORMs that we've extended with this whole notion of the tenant ID in there. So they can help you a lot with that migration. I believe for both Python and for Ruby, we have custom versions of the most common ORMs.
So you're talking about like Active Record, the Active Record multi-tenant gem for...
Yes, those.
For Rails, and then let's see.
Then again, Citus 10, single node. It's like start on that first node, directly distribute your table and model your data that way. The moment that you need more space, add nodes, rebalance your tables, and it's there for you.
Yeah, because now you don't need any more to have a full-blown cluster when you want to start, right? So
yeah, it used to be that most people started with 3 machines, 1 coordinator, and then 2 data nodes. Yeah. But it's quite costly if you're just toying around. So being able to do it on 1 machine now and have the performance of the parallelism that we add can help you a lot.
Yeah, we can all imagine what kind of machine you would run. So that's not the most cheapest way of getting started, maybe. So there was a question.
I would like to ask just a simple beginner's question. Postgre and Citus are quite new for me, but can you compare Postgre to Citus like a SQL database to Synapse Analytics? They're 2 different things, but the way it's a layer on top because of distribution.
I know too much about Synapse, I think, to give an unbiased answer. I think some parts you can achieve with SQL Server or a simple 1-node system and Synapse on top. Synapse excels in the data analytics space, where it kind of does this, I believe, columnar storage itself as well. The problem is keeping those systems up to date with each other. The tooling is great to do that, but nothing beats running your analytical queries live on the dataset as it's changing. Sometimes it's not desirable if you're wanting a snapshot of the data. So we have facilities that you can do that. But more and more you see that in the past we were doing ETL, and every 24 hours you ship your transactional database into your data warehouse for your business analytics. We see that time frame shorter and shorter. And when you run on production, it's you can't be faster.
Yeah, when I think about Citus and Postgres, a lot of people have an affinity for using an open source database, or their people are already trained and knowledgeable and expert in using Postgres and running on Postgres. It's also one of the simplest databases to get started with. and it's open source. So a lot of times they've already invested in Postgres, and then Citus is just a no-brainer. But like Neil said, the other benefit is it's not like you're keeping two different databases in sync. It's not like you're having to like do ATL transformations. You can do your analytics in Citus, in Postgres, as well as handle your transactional workloads too. So
Cool.
There was
I know-
this question, and I thought it was a real good one. Would you design your model for sharding from the get-go? So, like, I'm just making things up. I'm gonna get started. Let's do design mode. Would I take in the back of my mind, hey, maybe I want to shard it at some point, or should you wait until you need it?
I think that's the benefit of single node Citus, is that you can adopt a distributed data model from the very beginning when it's easy. There's no migration hit, or it's not a distraction from all of your other challenges of managing the growth of your application, right, and of your user base. So I would say that the feedback we're getting is that yes, people want to do that. Maybe not everybody, but I don't. Niels, pile on, please.
Yeah, no, single node is the enabler for that. It still depends a bit. If you run an application that will never need it, then the overhead of designing a data model that can hamper you in your early bootstrapping of your project. If you know that this can get really, really big, paying the cost up front is cheaper than a migration later.
Cool. And then I think there was a question about how do people get started or join the community. And so we did put a Slack URL on screen earlier. There's a lot of open source Q&A that you can join by joining that Slack. And we also had the newsletter URL up earlier too. And that's a way to get on a silver platter every month links to all of our best and latest technical blog posts. And I get to read all the blogs before they get published. And I have to say, I learn a ton from it and really enjoy reading them. So I hope you guys do too.
Yeah, and so there was this question about the community. So one of our viewers is interested in the data community, and was asking, how can I start? What meetups can you recommend? So yeah, I thought let's grab everybody in this discussion. And
well, there's this meetup called Contributing Today that I think is pretty good. I'm sorry, like I had to say it.
That's quite a good one.
yeah.
So for meetups, like before this whole pandemic, it was very locally oriented. So every city has their own data engineering meetups. If you look closely, sometimes they're hard to find. Data engineers, including myself, I'm not the best at marketing. So sometimes you need to look a bit for it. And otherwise, like we have never run our own meetups, but I know that Elasticsearch has done that. Spark has a local user community in every major city. So those are at least the places where I've learned it were those meetups.
I know in the Postgres community, there's an annual event called PGConf.eu, which hasn't happened because of COVID. And I don't know if it's going to happen this year. I haven't seen it announced, so I'm not sure. But it's wonderful. It's one of my favorite events on the planet. And it changes European location every year, and it happens in October. And so I've been to Lisbon and I've been to Milan, and I will go to wherever it is next, whenever it happens next. And there's also PG Day events that are one-day events that are super cool because it's not that big of a time investment, and they happen in all sorts of different countries and cities around the world.
Postgres user groups are there in every city as well, by the way. I forgot those.
Yes.
And Simon, how is it on your side of the spectrum?
Yeah, so there's just tons all over the place. I mean, that's the problem with the data community, is that it's distributed. in that you get like the Spark ones, you get the old like the Microsoft traditional ones doing SQL Server type stuff. You get the guys like doing Postgres. It's like almost like it's not just data. It's like you have to pick your favorite data tool, and then there's just a ton of different meetups for it. So it's kind of almost like pick a tool, and you'll find local groups in pretty much every city. I mean, London has all of them all competing, going, no, you should use Spark, no, you should use open source, no, you should use Synapse. It's rare to find like a general data engineering one. I've certainly found kind of lots of different flavors.
The best thing is like 40% of the people attending those are all the same. So you will run into a lot of the same people at different tool meetups.
And it's
Sounds
nice.
really efficient.
The thing is that you can just watch 24 hours per day now to meetups and learn new things because it's all online.
Well, the other big event that's about to happen virtually later this spring is PyCon. So, and that's usually happens in the US every year. And it's also one of my favorites. And they're in the middle of organizing it. Like, I think people who submitted paper or talk proposals to the CFP, they should be hearing back this week with whether they were accepted or not. So soon.
And historically, there's always a bit of a database track there as well. I mean, an old colleague of ours, Louise, has presented there, I believe. She dissected how Postgres does indexing. If you have time, look up the talk on YouTube. It's a really great presentation.
Oh, that was at DjangoCon. That's right. That was really good.
Yeah.
Yeah.
Great. So I think we heard quite some tips. So I hope the viewer is satisfied. The audience is waiting for the joke on how to join. Dear, I can't even.
Yeah, well,
how to join a data-centric user group. Okay, well.
Yeah, but join is capitalized, right?
Yeah. So what does,
it's hard to select the right one.
And one I promised to ask, what does Data do after losing his job? Roll back. Well, okay.
Oh my God. I hope my kids don't see this.
We need to. Okay.